To solve a triangle means to determine some or all of the unknown sides and angles of the triangle. We will be focusing our attention on solving right triangles. When labeling the sides and the angles, we often use capital letters for the vertices and label the side opposite the angle with the corresponding lowercase letter. For a generic right triangle, there are 2 unknown angles and 3 unknown sides. However, there are mathematical relationships that relate some of these values together. For example, we know that the sum of the angles of a triangle is 180 degrees, so we can write one of the angles in terms of the other. Similarly, the Pythagorean theorem tells us that if we know the lengths of any 2 of the sides, we can calculate the length of the third side. We also have trigonometric relationships that relate one of the angles with 2 of the sides, so if we know any 2 of those values, we can calculate the third. It turns out that if we know the length of one side and one other piece of information in the right triangle, we can calculate the lengths of all the sides and calculate all the angles. This is a matter of problem solving. Based on the picture, you have to determine which relationships you're going to use. And there may be many ways forward, but as long as your steps are valid, you will get the right answer. Example: solve the right triangle for all the unknown sides and angles. When working with these triangles, sometimes you will see the units explicitly listed and sometimes you won't. It's up to you to recognize that in this context, the number 7 refers to a length. It could be 7 inches, 7 centimeters, 7 miles, or some other unit. We would generically say that the side is 7 units in length. When it comes to word problems, the units will be specified in the problem, and you might need to do some unit conversions. But for this problem, we simply know that it's 7 units in length, and we can proceed from here. Let's start by determining the size of the third angle. Since the sum of the angles is 180 degrees, we can see that B is equal to 70 degrees. In fact, the 2 acute angles will always be complements of each other in a right triangle. Let's solve for the second leg. We can either use angle A or angle B. In general, it's best to try to relate things back to the information given in the original problem. This helps to minimize the chances that you make compound errors. For example, if we had calculated angle B incorrectly and then used that angle to calculate the length of the leg, then there's no way that we would get the right answer. So we will use the tangent of angle A to determine the length of the second leg. Tangent is opposite over adjacent, and we can solve for B to get 7 over tangent of 20 degrees. At this point, we can get a numerical approximation by plugging this into a calculator. Different classes treat significant figures differently, so we're not going to spend a lot of time worrying about this here. If you keep at least 4 decimals in these calculations, you should avoid most major rounding errors. Just as a reminder, when using your calculator, make sure that you have it in the right mode. We're working with degrees now, and so it should be in degree mode. There are several ways to determine the length of the hypotenuse. Keeping with the idea that we want to use the given values as much as possible, we can use the sine function with the initial angle. This gives us c is equal to 7 over sine of 20 degrees. There are several other ways to get the answer using our calculated values. In this case, everything happens to round off to 4 digits and correctly match up. However, there are some situations in which you will find differences in the third or fourth decimal. If you have errors larger than that, you've either made a mistake or you're rounding off too early in your calculations. You will want to be aware of this so that when you compare your answers with other students, you can have a sense of whether it's just a rounding error or something more. In the next video, we will learn some specialized vocabulary in preparation for solving right triangle word problems.